Hello, everybody. So let me introduce you today. This is the operation attribute table of an electric vehicle. Then this data cable head comes in here. What you see so far, we are controlled by this main control board, and this measuring board. And these main benches are composed of. And how about these measuring plates? We installed some terminals. And these monitors. It's something the BMS can detect. What about these monitors? Can it be operationed? For example, this is matched with the meter. This matches the gear. And this is it. An indicator left power on. So this is a switch. So we go through such a way to do the operation to start it. So what next? And I will just show you. Let me introduce you to everyone. We're a little part of the bench. So this is the tire. That is, we're going to. What about when the simulated car is driving? What about the tires? You move forward. Move it. Then this is the power battery. Power battery. So what about this one? Just the battery and the module. So this is one of its relays. Relay. So here is a high voltage and plug. High voltage plug. Then take a look at the high voltage plug here. The orange one, that's high pressure. What about the black one? Just the low voltage plug. Then you can get this one and this plug, right? Is this plug a maintenance switch? That is, we're in the process of repairing. We can put this repair switch, take it out, then who lose power? Play a role in power failure and maintenance. Switch. What about this high voltage plug? Or is it just one from power? What about an electricity in the pool? Come directly here. It's just a module of this piece. So this module is the motor controller. Motor controller. It is powered by the power battery to the motor controller. What about the motor controller? Converted to three-phase alternating current. Three-phase AC EV-WUW. Then comes the drive motor. Let the drive motor drive. Drive. Then we're going this way. What about here? Is it a car charger? That is, when we need to charge it. Then it is through this car charger, as a medium, to make a transition. So it's the one from this side. This is one of them. Is this a charging port? There's only one charging port here. When we plug in a 220-volt household electricity, after plugging in the charging case, power it up, then it's towards this line. To this line. To this line. This high voltage line. So here we are. Came here. Then it finally goes through this car charger. We also call it an OBC to do. Perform a transformation, converting from one of our AC to DC. Well, it finally got to a battery here. Does it charge the battery? Charge the battery. Okay, so we're going this way. So, here's a radiator. Radiator because of a motor here. Is it one? Use water cool for a cooling one. So we need a cooling tube like this to carry out a delivery of these coolants. And a radiator over here. Let's do a quick heat dissipation on it. Quickly dissipate heat, then go this way. So here is 1.5 axis of it. This is a half-shaft drive motor. Drive through the differential. Go to the half axis here. Give this wheel a spin. Spin it around. Yes, this way. This way. So this is the accelerator pedal. And here's the accelerator pedal. So this is an automatic pedal. This automatic pedal. So here is a booster. Just that. Does our vacuum have a booster? Is this one of his? Coolant. The brake fluid. Then go this way. This is a low voltage battery. Low voltage battery. We're equipped with this low voltage battery. Negative power switch. Negative power switch. So this is one of its tanks. He has a gas storage tank here. So this one is a vacuum pump. It's a vacuum pump. Then the hole is a whole part. Are we done? So let me give you a demo. So before the demo, we need to check. the stability of this device. For example, let's check the appearance of the meter here. Is the appearance of these gears normal? Then check a measurement side here. Is there any problem? Red, check if there is any problem with these. Then check one of the components here. Check if there is any loose thread. Check for loose wires. Is there a problem with the battery? Especially these high voltage plugs. These high voltage plugs. Let's check if it's connected properly. Is it connected? Check in place. Then we should also check it regularly. This brake fluid. Is the brake fluid in one of its standard ranges? Then this is the lowest level. This is one of its highest positions. Can't be too low. Can't be higher. The highest. It is most suitable in the middle here to check. Including checking the brake fluid here. Is the brake fluid in the appropriate range here? Okay. Check if it is stable. Okay. Then the check is stable. Then we are. Turn on this ignition switch for everyone. It's a negative on this side that switches to 1. Then it will be equivalent to turning on, equivalent to connecting well. Then come on over here and turn on the ignition switch. Also called the start switch. Okay, so let's open it again. Okay, so finally, turn it on. Wait a few seconds. Let the meter do it. To such a quality inspection, it is BMS that conducts a quality inspection on it. If there is a fault code, then it will pass through this meter. But can this meter? But can it show its failure? Here is its meter. Okay, so let's go this way. And when we boot it up, so what about this BMS? It will display relevant information. So says, for example, okay, we can see it. The current battery is 74.4%. So you can see it here. It's total voltage. About 80 volts, such a high voltage. So we're in the process of operation. Be sure to pay attention to safety. It is best to bring some insulating glass. We're insulating glass. Is that a voltage associated with it? Yes, can you see it? Is this one of its temperatures? One of its temperatures here is one of its temperatures. You can totally see it. This is the first and second. A message here. Wait a minute. We can see it. What about this way? You can see related information here. You can see it from here. A battery with a single voltage can be seen. The first group, that's the first cell voltage, 3.314 volts, 24/312 volts. So here is one of its temperatures. A temperature at 28, another temperature also at 28, not much difference. One is 28.1, the other one is 28.5, 28.5. This is a message related to one of its BMS. You can see here, it's a running state. Okay, so, draw an operation for everyone. Draw an operation for everyone. What about our current gear? Is it in a neutral state? In neutral, we're going to hit this automatic pedal. Press the automatic pedal. Then what? Put it in forward gear. Hang into forward gear. Put down the pedal. Step on the accelerator pedal. You see a wheel there. Is it driving? Okay, then you can also see one of its real numbers here. You can see one of its real numbers here. It's all around here. And what about when we stop? Or press the automatic pedal, and the car stops. We can also switch to a file. That's reverse. Then put down the automatic pedal. Press the accelerator pedal again. It will reverse. Reverse run. It will reverse and run well. Okay. What about after we run it? We can use a multimeter. Take a measurement of it. A related voltage. Okay, we can go to this panel. Signal can be measured. Voltage and so on. Do we use a multimeter? Set to 20 volt gear. Such a voltage is direct current. Then use a multimeter. Insert red dial. Plug it into the red terminal. the red terminal powered here. What about the black watch pen? Oh, just plug it in. Black terminal. We can measure. One voltage here is about 12.58 volts. Is this one of its supply voltages? In the same way, we can also be here. Let's run a test on it. For example, this is one of its motor controllers. We can also measure this part of the motor controller. Is there a power supply voltage signal here? Can you measure it? You can measure it. Okay. So, we can also learn. Or in practice. Can you make a setting failure on it? That. Okay. Can we use a tablet or a phone? Just open a fault setting system here. So it will jump out of a position here. Then we choose EV. It represents a training platform here. I Wi-Fi, click EV. Okay, what about after clicking? It has a scan here finished. Then click the upper right corner to enter. It will connect successfully. Then click Keep Connected. We will click on the assessment mode. The password is 6/8. Okay, so is there a signal here? So let me give you an example. Take one of them. Like what are we doing now? Take terminal R. What about terminal R? It means a motor here. No 7 of the controller. Let's click number here. Turn red. Turn red. Then yes, it represents a setting failure. Okay, so we can use a multimeter resistor. Come and verify whether it is set successfully. Okay, let's set it to a resistor gear here. Or buzzer gear. Let's check it out. A signal here. The black watch pen fit into one of the terminals above. What about the black watch pen? Fit into one of the terminals below. Okay, so it goes to infinity. It means that it has been set successfully. Then let's restore it. Okay, there's a beep. Make a beep. It means I have recovered. It means it is restored. So what about now? Put it in such a setting. A fault state. Okay, let's take a look at what's wrong with it. We also hit the automatic pedal and put it back in the neutral gear here first. So let's take a look again. What about the corresponding terminal node to here? It should be a file. Corresponds to their file. Okay, so what? We use one of the gears here. Set it to our gear. Set to our gear. Let's press the accelerator pedal again. It's not working. It's not working. Under normal circumstances, we get into gear and press the accelerator pedal. It runs from one side to the other. So it's not working now. It means that there is a fault phenomenon. Okay. So we use a multimeter over here. Let's do a measurement verification. Look at the voltage here. The voltage here is good. Set this side to voltage gear. Adjust to voltage gear. Then insert the red watch pen into the red terminal. What about the black watch pen? Insert one here. Oh, the blue terminal. What about its current voltage? It's 80 volts. The current voltage is 0 volts. What about putting it back? What about after putting it back? Also a 0 volt state. Then let's change the watch pen to take a look. Under normal circumstances, what should be here? 3.2 volts, right? 3.2 volts is good. So this is 0 volts. Explain what? That means that there is a voltage asymmetry here. There may be an open circuit phenomenon. So where are we now? Restore it and operate it. Restore it and operate it. Take a look at one of its voltage changes. Click the red one here. Is there a button here? It turns green. It turns green. Then in this state, we are. Test again. Check if it is successful. Step on an accelerator pedal. Here. Hang up a gear. Okay. So let's take a look again. Still not so much of a problem. Oh, because after we cut the circuit. What about the computer? What else is there? Still in a dormant state like this. So what to do? Are we going to turn off the ignition switch here first? Turn off the ignition first. Wait a few seconds. Then let's power it up again. Then it will really perform a recovery. So after hearing the sound of this relay, we represent that it is truly recovered. Okay, so let's take a look again. Put it in a reverse gear here. So let's hit the accelerator pedal again. So let's restore it now. One of its faults. Restore it. Then press the red button here. What about after pressing? So it becomes a green state. After the bubble turns green. Let's try one of its faults. Is it really recovery? Press the automatic pedal. Handing tail large gear. Then step on it again to accelerate. So what does it mean that it works? Does it mean it has already succeeded? It has been successful. The recovery is successful, right? Then let's look at the voltage here again. The voltage here. What about the voltage here? It's a state on the 3-point volt side. Then we are under normal circumstances. If you put it in reverse gear, it should go directly to 0 volts. This stable state. Then in the case of the faulty side above, then twice when we hung up the file, there will be 0 volts. It must be inconsistent with this side. Okay, when we're done training, we have to withdraw this directly. Just quit. This is good. What about the watch pen? Just pull it out. Pull it out and turn it off, and then what? Okay, then restore it here. Then hang one here. Turn off the power switch here. Then disconnect the power switch and pause. When we see a SOC here. What about below 20%? Well, we can actually charge it. That is to say, the power battery has lost power. Are we going to charge it? Then how to charge it? We need to plug the charging gun here. To be connected to the equipment of the training table, then plug the charging gun into a socket here. Plug it into the socket here. Then aim it directly at the charging gun plug into this side. Okay, then you'll hear the charge. A flame out of this relay. A voice. There is sound. Then we can see it here. An indicator light here. The red light is flashing. It is also said that when it is less than 80% here, flashing here. What if it is greater than 80%? The red light is flashing. If it is full, then one of the green lights here is flashing. So it means he is charging. And we can see that as well. Then we can see it. Is the indicator light showing here? It means it is normal charging. And again, we can see it over here. What about when we charge it? The car charger. Its fan will turn. The fan will turn. The one just now will means that it charges the power battery normally. And that's it for today. Diagnosis and maintenance of high voltage contactor. What happens when the high voltage contactor fails? The high voltage cannot be turned on normally. So we're going to test. Is the power supply of the high voltage contactor normal? Okay, we plug the watch pen directly into the BMS in such a jack. And we went to measure one of his supply voltages. Okay, so it's about 10 volts. If there is number 10 volts to measure his voltage, there may be a problem with the contactor. Or a contactor on his side. There's a corrosion. Such A1, there is one such one. It has corroded such as that. Can we pass the red light here? Can you see it? You can see that the relay is normal. Detection of charging system. When we don't charge the power battery, the voltage measured now is CC and line 2. So the current voltage is 8.6. Okay, let's insert the charging gun into the charging port. Okay, now what? When charging it normally, it's the arrows. The voltage here is obvious. Width has increased. What if we have a failure? So its voltage won't rise again. So it's obvious to me that it can. embody such a judgment. Yeah, it's logical. This is a power battery. It's made up of 24 cells. In series, this is a BMS. BMS real-time monitoring of voltage and current of power battery. Temperature, etc. So this piece is one of its relays. Then this includes the charging relay. Pre-charge relay. The main positive relay and the main and auxiliary relays are composed of. And here's one of its high voltage plugs. When we go up, after the electricity, power is being connected by the main and auxiliary electrical suction. Then it is sucked in by the main positive wire, and then what? Without charging, that is to say, in the case of high voltage, we diagnose and test it. Then let's find it. Such a measurement terminal. Set the multimeter to 20 gears. Then what about the black watch pen? What about the red watch pen? Put this anti-D in. Take this anti-D as an example. What about a low voltage resistance measured? Is it around or 3 volts such a voltage? So what if he is faulty? It's usually more than 2.5 volts. If it is greater than 2.5 volts, he has a fault. So this is the same way to look high. The same way. Just directly judge this one who looks at the line. Such a failure. So when this watch line fails, then he can't get in here. Send a message to the motor controller. Then there will be no way to proceed. That's what drives this matter. Measurement of current in power batteries. We're going to use a forward ammeter. Set the ammeter to 40 amps DC. quadruple amps. Then we apply high voltage electricity to the power battery. After applying high voltage, we use dive watches. Directly at the power battery, C. The terminal of a bus of a high voltage plug at the C end. We can measure one of its currents at 1.7 amps. Unit is 1.61. Then on LBMH. You can also read one of its current values. The current value you are looking at now is 1.4. So the current we just measured is close to 1.7. If it is close to the value of the current, it's between 1.3 and 1.8. Next, we use the dive watch to continue measuring the drive. Motor current. We put the front table. Turn to the same. So we set the meter straight. Go straight to a gear like 40 amps. Set the forward gauge to 40 in gear. Then press select. Select AC. And then we tested it. A current on his side. Okay, so one of the currents measured now is 0. What's the cause? Oh, we're not in gear yet. Okay. Then we hang up the D file or the L file. Then press the accelerator pedal. Okay, press the accelerator pedal. Then we can see a current on his side. Shows about 30 amps of such a current. Same method. Let's do a CP check on CC. In the same way we do a test for CP. Oh, so when we didn't charge the charging gun, we didn't give power batteries when inserting the charging gun. So now the CP line run and to currently measured, the voltage of the ground wire is 0.6. What about the same method? What about the charging gun? Plug it directly into the charging port. Then its voltage will change. It goes from 0.6 to 1.1. It's charged normally. It's charged normally. So who do we see now? Here is a voltage around 1.17 volts. Oh, this is the charging system. Such a diagnosis and repair. What if there is a failure? Oh, then the voltage will not increase again. A detection of a temperature sensor. So we set the multimeter to a resistor. Here. Adjust it to a bound. Round R, 000200K. Then we have to turn off the ignition switch. Turn off the ignition switch. Wait a few seconds. Wait a few seconds. You can even disconnect the negative electrode. We make measuring the resistance of a temperature sensor with a watch pen. Black watch pen into T1. What about the red watch pen? We measure its resistance. What about its organization? There is an organization like it's close to 10,000 euros or so. What if we say that the measurement is not within this range? Probably not in this range. So what about this temperature? There will be failures. So of course, we can say that the temperature is faulty. After we can fully power on, go inside BMH. Is the temperature value you see normal? Here is the temperature displayed. The normal temperature is between 2830 and 2830. Such a normal temperature. If the temperature is too high, then maybe the temperature is too low. Then he will power down. Direct high voltage. Throttle. A detection of accelerator pedal sensor. So first, let's look at the malfunction phenomenon. When this accelerator pedal sensor fails, let's take a look at one of its failure phenomena. Turn on the ignition, hang SD file. Let's hit the accelerator pedal. Check if it is driven. Hi, found out. Can't drive. Found that it couldn't be driven well. So let's set the multimeter to 20 volts. Such A gear. OK, use the red marker to insert. Insert fault signal. Such a terminal. Black watch pen. Plug in one terminal of a signal here. OK, so what we're measuring now? One of the voltages here is 0 volts. Go ahead. Press the accelerator pedal. EOM is 0 volts. Illustrates a malfunction in the accelerator pedal. Under normal circumstances, we measure the signal here. When it is not stepped on, it's around a few tenths of a volt. Such a measurement, as mentioned earlier. And after you step on the accelerator pedal, I go gradually, increasing gradually. Then roll out. In the same way, we restore it on the tablet. Then what? Turn the ignition back on. Open it again. Then put it in gear. It can run normally. Then the normal voltage can be measured here. From the circuit diagram we can find. Automatically switch this piece on and off. 2 wires. Accelerator pedal 3 wires. OK, so what do we do now? Use a multimeter to test one of its signals. So the first thing we do is we actually turn on the multimeter. Adjust the saturation gear at 20 volts. Crane automatic pedal. Insert a watch pen, a stitch. Another watch pen inserts another pen. OK. Do it all over again. A watch pen is inserted into one of the pins. Another watch pen inserts another pin. Without pressing the automatic pedal, one of the voltages being tested right now is 2.24 volts. Then we hit the automatic pedal. After pressing the automatic pedal, its voltage shows 0 volts. Low positioning such a voltage that 0 volts. OK, so it says 0 volts. And then we tested the accelerator pedal. So the accelerator pedal has a total of 3 wires. So this is a 5-volt power cord. This is the ground wire. This is the signal line. First we insert the back watch pen into the D line. That's pin 3 on the side of the log. Then, what about the back watch pen inserted into one here? The power cord is then tested for a voltage. One voltage of 5 volts. This is the power supply voltage of the accelerator pedal. OK, so then we test the voltage of the signal line. The red watch pen is inserted into a gear here. Then what is tested is, without pressing the accelerator pedal, voltage is 0.82 volts. So let's hit the accelerator pedal. The voltage measured by pressing the accelerator pedal is 3.7 volts. This situation is over. Depress the accelerator pedal. OK, so the current situation is such a one. Aha. $5 volts when still. 2.5 volts at work. When still, you have to jump from 5 volts to 0 volts. A diagnosis of the encoder. So first, let's look at the malfunction phenomenon. Turn on the ignition. Turn on the ignition. Then press the automatic pedal. Then set it to DOR. Then we step on. Accelerator pedal. Hi, the motor is not running. Motor does not run. If it doesn't work, please power off directly. Power down directly. We use multimeters. Measure one of its signal voltages directly. Insert the red dial into the HV signal terminal. Black watch pen insertion GND. So the current measured voltage is 0 volts. A repair of the Hall sensor. So this is the Hall sensor. So the Hall sensor is powered by 5 volts. Just insert the pen directly into it. A port for the Hall sensor. The left is positive. On the right is the negative electrode. Then test one of it. That's one of its 5 volt supply voltages. When we measure that there is number 5 volts, then it may be a fault with the Hall sensor. The signal voltage detection and diagnosis of Hall sensor. So what about the watch pen? Insert this directly. Or corresponding. One terminal of the signal of a Hall sensor. Then measured. The voltage measured by a Hall sensor is about 2.5 volts. A voltage here. inspection and maintenance of automated systems. So we turn on the multimeter. You got into gear. Same method. Enter the number 9 with the red marker. The black pen enters number 8. Same method. Put the red marker into number 8. The black watch pen is poured into number 9. We can see it. The current voltage is 2.35 volts. Then we hit the automatic pedal. Okay, so he's currently measuring 0 volts. Then this is his normal situation. When we say there is a malfunction, then his voltage. It's usually around R, 33 volts, the voltage here. What happens when we hit the automatic pedal? He is unresponsive. He's always been for 2.33 volts. It won't become low positioned. So this was one of his methods. Then we can see here's a malfunction on the automatic pedal side. A full diagnosis and elimination of encoder. We have already talked about diagnosis and maintenance. Now let's talk about exclusion. When we found out it was the motor's problem, so let's pull it back down now. We recover the failure on the tablet. What about disconnecting the ignition? Disconnect ignition switch, then wave the power down for a few seconds. Power off. We will turn it on after turning off the power. Turn the ignition back on, then put it in the file. And then we hit the accelerator pedal. Okay, then the motor starts running. Explain what? Does it mean that the failure has been restored? Normal voltage now. This is about R volts. Such a normal voltage.